Hi students. In this video we're going to go over analysis of stresses caused by centrifugal forces. So imagine you're analyzing, say, a jet engine disk or a spinning flywheel, something like that, something that wants to hurl itself outward. Okay, this model is quite hard to deal with as it is. However, we have something called cyclic symmetry, which allows us to analyze only a portion of the model, and that will make this analysis much easier. I already have a quarter wedge of this model modeled, so we'll come over here, and this is what we're actually going to analyze. So we're going to do a new study. It's going to be static. That may be counterintuitive, but you'll see why it works in a moment. Okay, so now we have to fixture the object in space for our FEA analysis. So I'm going to choose fixed geometry, and I'm going to choose roller slider this time. I'm going to apply it to that face. So now this face is only constrained in the X direction. It could still move all around in the YZ plane. Okay, I'm going to apply another roller slider on this face. So now the model cannot move in the Y direction. It can really only move radially, and it could also move in the Z direction. So let's make sure it can't move in the Z direction. I'm going to apply a zero displacement right on that vertex. I'm going to add another fixture, fixed geometry. This time I'm going to use reference geometry. I'll choose the vertex. Then down here, I'll choose the edge to align to. And you can see the little arrowhead popped up. And we specified zero translation. Okay, so that fixes our model in space, even though it can grow radially. The next thing we're going to do is we need Solidworks to consider this as a full disk, so we need to apply our cyclic symmetry. We're going to do fixed geometry again, and we're going to go under advanced, and lo and behold, there's an icon with a little pi wedge. Let's try that one. So we're going to choose the first face, second face, and then we have to choose an axis of rotation. And SolidWorks previews what it's going to consider. Now, the important thing to remember about cyclic symmetry is that any displacements on this face will get mapped over to this face. And that's an important concept with cyclic symmetry. So for example, if this bottom edge were to move out, say, a quarter of an inch, then this edge would also have to move out a quarter of an inch, because we're saying make it a repeating pattern. Okay, so we will accept that. The next thing we need to do is apply the load to our model. So we're going to come under external loads, and we're going to apply a centrifugal force. We're going to choose selected reference, and that's the center of rotation, and the speed that we want to rotate, which in this case is 60 Hertz. That would equate to 3,600 RPM, typical for a small two-pole motor. Okay, so that's it. We're now constrained in space. We've applied our load. The model can grow radially. We will mesh it and transfer the loads to the mesh. There we go. Our mesh looks good. And let's see. One thing I didn't do, I did not apply a material. So let's apply 1020 steel. Okay, good. Now we have 1020 steel. And let's run it. There we go. Whoops. And as always, we get von Mises stress. In this case, von Mises is not the most appropriate stress to look at. This would be far better analyzing for S1 principal stress. So we'll edit the definition. I'm going to choose true scale, first principal stress. I'm going to say OK. I think I'll also change that to MPa this time. There. Okay, so that's looking like a pretty good model. I did do the hand calcs, and it says that the bore stress should be about 2.5 MPa in the bore. So let's probe it. I'm going to come under probe. Okay, we are showing higher than expected from the hand calcs. We're off by a factor of about 2. So that is something we should look at further. However, we're not off by orders of magnitude. And in this analysis, we are considering things like the bore thinning out because it's holding on to all the material that wants to expand radially. Okay, so let's take a look at our displacement. So how far did this grow? I don't see enough decimal places, so let's change that. We'll go under Edit Definition, and then under the Chart option, I'll increase the number of decimal places. So, not too much. And you can see the impact of our constraint, only allowing that one vertex to remain fixed in Z. So if we look at displacement in the Z, so you can see that this face actually moved in the Z direction, and this whole thing thinned out and moved in the positive Z, which is kind of interesting, which is exactly what it would do in reality. Okay. So there you go. That is how you analyze for centrifugal stress. So I hope this helps with the MEE challenge this semester. Thanks for watching.